Welcome to CH225 course on Statistical Data Analysis for Chemists. I am your instructor, Anil Kumar. These are my contact details. This is video 29 in this series. In this video, we will learn about the degrees of freedom. Degrees of freedom is an important term used extensively in data analysis. For some people, it is not so easy to understand and appreciate it, therefore, we are dedicating a special video to understand this important concept. The broad definition of degrees of freedom is the number of independent indicators for the same information. For example, let us say that we want to measure the temperature inside our reactor. To do so, we can either use one or two or many temperature sensors. These sensors could be of the same type or different. So the degrees of freedom to measure temperature of our reactor is the number of sensors used. What do you think, how your confidence changes with number of sensors? I am sure you all agree that your confidence level in predicting the temperature inside the reactor increases with increasing number of sensors. Therefore, degrees of freedom is directly related to confidence in our predictions. Higher is the degrees of freedom for a given prediction, more confident we are. How about predicting the temperature inside the reactor without using a temperature sensor? How confident will you be in your prediction? You will not have any confidence in your prediction, as it is a pure guess. Therefore, you need at least one sensor to have some confidence in your prediction. Of course, higher the number of sensors, more is the confidence level. In other words, you need at least one experiment, which is measuring temperature here, using a sensor to predict temperature. Or, minimum of 1 degree of freedom is required for any prediction. The confidence in our prediction increases as the degrees of freedom increases. Let us take another example to get more clarity. Imagine measuring the height of the male undergraduate students in IIT Bombay. We selected a random group of 200 students. 6 volunteers were assigned to measure the height of each of these 200 students. Now you have generated 6 data points for each of the 200 students. Therefore, you have done total number of 1,200 experiments. Now, if you are interested in the height of any student, then the degrees of freedom for height is 6. If you use the average of these 6 measurements, and then calculate the average height of 200 students, your degrees of freedom for average height will be 200. Now, you can create 10 groups of 20 students, and then calculate the average height of each group. Your degree of freedom for the average group height will be 20. You can now calculate the mean of the average height of these 20 groups, to get the average height of 200 students. This is the same as the expected value of the sample means. Degrees of freedom for this will be the number of groups, and that is 10. Let us now understand the physical significance of this independence term. Remember our original formulas for calculation of sample mean and variance. If you note, we used n in the denominator for sample mean, but n-1 for sample variance. Do you know why? This is related to degrees of freedom. What we are saying is that the degrees of freedom for sample mean is n, whereas it is n-1 for sample variance. It is easy to understand this for sample mean. Since we need to do n measurements to get our data set to calculate sample mean, the degrees of freedom is n. Let us try to understand why degrees of freedom is n-1 for sample variance. Please recollect what all information is needed to calculate sample variance. We need sample mean and data values. However, we don't need all the data values, as we can afford to measure only n-1 values. This is because the one missing value can be determined if we know the sample mean. Do you know how? Remember the property of sample mean, wherein the sum of the deviation from the sample mean is 0. Therefore, we need only n-1 measurements if sample mean is known. Therefore, the degrees of freedom for sample variance is n-1. We can use another approach to explain the degrees of freedom for sample variance. Let us say that we did n measurements and hence our total degrees of freedom is n. Remember, degrees of freedom is equal to the number of measurements. Out of n degrees of freedom, we used 1 to calculate sample mean. Remember, you need minimum of 1 degree of freedom to calculate any parameter. Therefore, we are left with n-1 degrees of freedom for any other measurement, such as variance in this case.